Dear students, welcome to the session on Milne Thomson's method. In this session, we are going to construct an analytic function f of z. Either the real part or the imaginary part is given in the problem. Sometimes the real part will be given to us. We have to find the imaginary part and vice versa. Whenever we say the function f of z is analytic, then we remember it satisfies CR equation ux equal to vy and uy equal to minus vx. Now we are going to change the function f of z either in terms of u or in terms of v according to the given problem. To achieve this, first we have to differentiate the function f of z with respect to x. So we get f dash of z is equal to ux of x comma y plus I into vx of x comma y. Since u and v are functions of x and y, we have to differentiate partially with respect to x. Since f of z is analytic, it satisfies CR equation. I want to change this equation in terms of u. So we know that uy is equal to minus vx. Replacing vx by minus uy, we can achieve that f dash of z is equal to ux of x comma y minus I into uy of x comma y. So now this f dash of z is completely expressed in terms of u. Similarly, suppose I want to express this f dash of z completely in terms of v. As usual, we have to differentiate f of z with respect to x, and then we have to change everything in terms of v. So by CR equation, we have ux equal to vy. Replacing ux by vy, we get the new equation f dash of z is equal to vy of x comma y plus I into vx of x comma y. So here f dash of z is completely expressed in terms of v. Now let us see the working rule for Milne Thomson method. In the problem, if the real part u of x comma y is given, then we have to find f of z, that is u plus iv. First identify whether it is real part or imaginary part. In our case it is real part, so write the real part, and for the real part find the partial derivatives, that is ux and uy. Once you find the partial derivatives, now x should be replaced by z and y should be replaced by 0, and we have to find ux of z comma 0 and uy of z comma 0. This is my step 2. Just recall, we found f dash of z in terms of u, ux of x comma y minus I into uy of x comma y. So by Milne Thomson's method, I can replace this x by z and y by 0. I can write this as f dash of z is equal to ux of z comma 0 minus I into uy of z comma 0. Once this is done, I can integrate this f dash of z to find my analytic function f of z. In the similar way, if the imaginary part vx comma y is given, now we have to find f of z. So just identify v, that is step 1. Step 2, we are going to find the partial derivatives of v, that is vx and vy. Once this is done, we have to replace x by z and y by 0 to find vx of z comma 0 and vy of z comma 0. Since the imaginary part v is given, we can recall f dash of z is equal to vy of x comma y plus I into vx of x comma y. Now by Milne Thomson's method, replacing this vx of x comma y and vy of x comma y by vx of z comma 0 and vy of z comma 0, we get f dash of z is equal to vy of z comma 0 plus I into vx of z comma 0. Next, step 4, integrating on both sides, we get the analytic function f of z. Hope you understand. Now just have a quick recap in a nutshell. If real part is given, we have to find the analytic function f of z. Similarly, if imaginary part v is given, we have to find f of z. Step 2, if the real part is there, for the real part we have to find the partial derivative ux, uy, and for the imaginary part we have to find vx Vy, and x is replaced by z, y is replaced by 0 in both the cases, and we have to keep ready. And step 3, by Milne Thomson's method, I can replace this ux of x comma y by ux of z comma 0 similarly in the other part. So we get f dash of z. By integrating on both sides, we get the analytic function f of z. So this is the working procedure to find f of z, whether the imaginary part is given or the real part is given. So for the real part, we have to find ux, uy. For the imaginary part, we have to find vx, vy. And for the step 3, we have to remember if the real part u of x comma y is given, then f dash of z is ux of z comma 0 minus I into uy of z comma 0. If the imaginary part v of x comma y is given, then f dash of z is vy z comma 0 plus I into vx z comma 0. You have to remember this key point. If it is real part, it is going to be ux minus iuy. If it is imaginary part, it is going to be vy plus ivx. Just simply remember, if real part is there, f dash of z is ux minus I uy. If it is imaginary part, then f dash of z is vy plus ivx. So you can easily remember the formula in problem solving. So once step 3 is done, we have to integrate this f dash of z to get the analytic function f of z. So the key idea here is, in both the cases, x is replaced by z and y is replaced by 0. And finally, we have to integrate the f dash of z on both sides to get f of z. Now let us move into a simple problem. Determine the analytic function. So we have to find f of z whose real part is given. So u is given to us. Step 1, u is given to us. So write the u. Step 2, partial derivatives. Write the u in the first column, and then after finding the partial derivative ux and uy, we are going to replace x by z, y by 0. So differentiation of ux is 3x square minus 3y square minus 6x. The remaining two terms doesn't have x, so it is 0. In the similar way, differentiate u partially with respect to y, we get minus 6xy and minus 6y. Now replace x by z and y by 0. So ux of z comma 0 is 3z square minus 0 plus 6z. So 3z square plus 6z. When you come for y, uy of z comma 0 is minus 0 because it consists of y in both the terms. So uy of z comma 0 is 0. Step 2 over. Now let us keep the results ux and uy. Step 3 is applying the Milne Thomson's method. We know that f dash of z is ux of x comma y minus I into uy of x comma y. By Milne Thomson's method, I am going to replace this by ux of z comma 0 and uy of z comma 0. And we know that ux of z comma 0 is 3z square plus 6z minus I into uy of z comma 0 is 0. So we get f dash of z is 3z square plus 6z. Step 4, to find the analytic function f of z, I want to integrate on both sides. Integrating on both sides, we get 3z cube by 3 plus 6z square by 2 plus c on the right hand side. On the left hand side, we get f of z. Cancelling these terms, we can write f of z is z cube plus 3z square plus c, which is the required analytic function. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.